Alright, so now we're going to take a look at the homework for 7.2 section 3 where we're actually working the proofs. So you had 2 through 20 even. Number 2, we've got if n then d and w, d then k, n, therefore n and k. So with n and k, the dot there, we know the last step is going to have to be conjunction. We've already got the n, so what we need to do is work on getting that k by itself. Well, looking at what's present here, lines 1 and 3 would make a modus ponens. If n, then d and w, n, therefore d and w, 1, 3, modus ponens. And then we can simplify d and w to just d, like that. And then lines 2 and 5 make a modus ponens. If d, then k, d, therefore k. And so now n is on line 3, k is on line 6. We can use conjunction to stick those together. And so we know that one is valid. Alright, number 4, we've got h or not b, then r, h or not m, then p, h, therefore r, n, p. Again, two things joined by the dot means a conjunction. And we can see them right here, r and p, is the two consequents of those two conditional statements. So we need to get the two antecedents. Well, line 3, we've got h. Using addition, you can add anything you want. So we want h or not b, so we're going to add the not b to line 3 through addition. And now 1 and 4 make a modus ponens. H or not b, then r, h or not b, therefore r. So 1 and 4 are modus ponens. Now, for this p, we want h or not m. So we'll go back to line 3 with the h, use addition to add a not m. And 2 and 6 make a modus ponens. H or not m, then p, h or not m, therefore p. 2, 6 modus ponens. And now we've got the r on 5, the p on 7, so we can use conjunction to stick those together. And that one's proved. Number 6, we have if L or T, then B and G, L, N, K if and only if R, therefore L or B. Once again, we want to get the L and the B on separate lines, so we can use conjunction to stick those together. We can get the L very easily from line 2, L, N, K if and only if R. We can use simplification, and that makes that L. And now we have to work on getting the B. Well, again, the B is in the consequent of this conditional statement, so to set up a modus ponens, we need an antecedent, which is L or T. So the L on line 3, we can use addition to add whatever we want, so we're going to add a T to it, like that. And now 1 and 4 make that modus ponens. L or T, then B and G, L or T, therefore B and G. 1, 4 modus ponens. And then we can simplify B and G to just B. And now there's L on line 3, B on line 6. Use conjunction to put those together. And number 6 is proved. Number 8, we have if N, then B, and O, then C, Q, then N or O, line 3 is Q, therefore B or C. All right. So looking at this one, we can see right off that 2 and 3 make a modus ponens. If Q, then N or O, Q, therefore N or O. 2, 3 modus ponens. And now we can also see that 1 and 4 will give us our answer through a constructive dilemma. If N, then B, and if O, then C. N or O, the two antecedents joined by the wedge. Therefore, B or C, the two consequents joined by the wedge. Okay, 1-4, constructive dilemma. 10, we have D or E, then G and H. G, then not D. D and F, then M. All right, so this one's a little bit different because we are looking for a conclusion that isn't actually even in the equation. So you know that at some point you're going to have to use addition in order to put that in. We don't know where or how yet, so all you can really do is, like we did at the beginning, forget about that for now. Look at the premises and just try to see what you can do with this. And so the first thing I notice is that D and F, I can use simplification to make that a D. Okay. Now once we have that, we have some other options that are open to us. I think that if we use the rule of addition, we could make that D or E like that. In that way, 1 and 5 would make a modus ponens. D or E, then G and H, D or E, therefore G and H. And now, G and H could be simplified to just G. You see, we're just kind of working through and solving what happens to show up, looking for an opportunity, and I think we're about to find one. 2 and 7 make a modus ponens. If G, then not D, G, therefore not D, 2, 7, modus ponens. Okay. Now, we have a positive D and a negative D. Now's the time to add that M in. We'll take line 4, D, and use addition to add an M, D or M. And now 8 and 9 make a disjunctive syllogism. It's either D or M, it's not D, so it has to be M. 8, 9, disjunctive syllogism. And so even though the M wasn't in there, we were able to figure out, simply by working through it, how to reach that conclusion, proving that the argument itself is in fact valid. All right, moving on to 12, we have P then R and M then P. P or M, then P then R. P or M, therefore R or P. All right. So looking at this, the fact that we have two conditionals joined by a dot, and the conclusion being R or P, the two consequents joined by the wedge, my thought here is that we should have a constructive dilemma. This one, I'm making sure that I copied this right because this looks far too easy. Oh yeah, I didn't copy it right. That's the problem. There's supposed to be a, I was going to say, that was way too easy. That's supposed to be a horseshoe there. Okay. Sometimes copying these are the hardest part. Alright, so now it becomes a little bit more complicated for us. Alright, so now what do we have if we look at this? Well, 2 and 3 we have a modus ponens. P or M, then P then R. P or M, therefore P then R. 2, 3, modus ponens. And it looks like, again, 1 and 4 P then R, then M then P then R, therefore M then P, 1 and 4 modus ponens. Now, we want the R or P right there, P or M right there, so we'll need a conjunction on 4 and 5, P then R and M then P, like that. And so now we can draw our conclusion of R or P from 3 and 6 through a constructive dilemma. Right, P then R and M then P, P or M, the two antecedents joined by the wedge, therefore R or P, the two consequents joined by the wedge. Okay, so that was a little tricky. 14. F then, not T and A. Not T or G, then H then T. Number 3, F and O, therefore not H and not T. All right. So the conclusion being not H and not T tells me again that what we're looking at is conjunction at the end point. So we need not H and not T by itself. So we're just going to play with this until we figure out how to make that happen. So on line 3, you've got F and O. We'll simplify that to F. And now 1 and 4 make a modus ponens. If F, then not T and A. F, therefore, not T and A. 1, 4 modus ponens. Then we can simplify that to make it just not T. And there's half of the equation right there. Now we want to get to that H. Well, that means we need to get this part isolated, so we'll need the antecedent, not T or G. So on line 7, you've got not T. We'll use addition to add the G. And then 2 and 7 would give us if H then T from modus ponens. Now 6 and 8 would make a modus tollens. If H then T, not T, therefore not H. And so now we want to take the not H from line 9 and the not T from line 6 and use conjunction to stick those together. And we have that one proved. So number 16 now, we have C or not G. Then P and L. So P, not P. Not P and L. 2 is not P and C. Then C, then D. Line 3, C and not R. Therefore, D or R. All right. My hunch is that since we want a conclusion of D or R, and I don't see but one individual conditional, that we're probably going to be looking for D by itself so we can use addition at that final step. But let's just play with what we've got here and see what we can do. So line 3, C and not R, we'll make that C through simplification. Yeah, well, I think the easiest route to take for this, line 2, you've got not P and C, then D. Not P and C can be simplified to C, then D from 2 through simplification. 4 and 5 make modus ponens. If C, then D, C, therefore C, then D. 4, 5 modus ponens. 4 and 6, C, then D, C, therefore D, modus ponens. And then D, we can add whatever we want, so we'll add the R, D or R from 7 through addition would take care of 16 as being proven. All right, so that brings us to 18, not H then, not T then R. Number 2, H or E then F. Three is not T or E. 4 is not H and D. And so the conclusion we want to reach is R or F. Okay. Now I'm thinking constructive dilemma, R or F, and right here these two conditionals with R and F as the antecedent, and in fact right there not T or, the consequent, and then not T or E right there is the antecedent. So we just need to get those by itself. And that seems easy enough. We've got on line 4, not H and D becomes not H through simplification. 1 and 5 make a modus ponens. Not H then, not T then R, not H therefore, not T then R. 1, 5 modus ponens. And then lines 2 and 5 make a disjunctive syllogism. It's either H or E then F. It's not H, so it has to be E then F from 2 and 5, disjunctive syllogism. Well, now we can use a conjunction to stick these two together. We have not T then R and E then F from 6 and 7 through a conjunction. And so sure enough, not T then R and E then F, not T or E, line 3, therefore the consequence joined by the wedge, R or F, which is what we're looking for. And that is 3 and 8 as a constructive dilemma. And so 18 is proven. And finally, that brings us to number 20. M or N, then F, then G. Line 2, D, then not C. Not C, then B. 4 is M and H. 5 is D or F. Therefore, the conclusion we want, B or G. Okay. So again, B or G, given the number of conditionals, we're probably looking at a constructive dilemma again at the end. But let's see. Well, here we've got D or F. There's F. So we need the D, I think, is what we're looking at. So right here at lines 2 and 3, we could make a hypothetical syllogism. If D, then not C. If not C, then B. Therefore, if D, then B. 2 and 3, hypothetical syllogism. Now, we want to get this by itself. So we need the M or N. Line 4, you have M and H. We'll make that M through simplification. We'll use addition to add the M, make that M or N from line